Thanks, Mark. So yeah, I'm going to talk about context and contingency, and sort of how we choose tools using Elasticsearch as a lens through that, and our ELK stack. But really, first off, when I go to these conferences as an attendee, and honestly, like as a speaker, it helps to just get a little loosened up in the morning. If you guys can just bear with me for a moment, can we all do like a little stretch? Let's stick out our hands. Here we go. We're going to do this. We're going to wiggle our fingers. Wiggle our fingers. All right. If you awkwardly touch somebody near you, just mumble an apology. All right. Now sort of rock back, like little side to side thing. Roll your shoulders. Now try to sit up really straight in your chair. There you go. You guys are amazing. You guys, that was so fast and responsive. If you're like me, you feel slightly happier now than you did a few moments ago. I moved to the area here about a year ago and really didn't know what to expect. This is kind of on a personal note. And I've just been really amazed at the vibrant DevOps community here. Really cool stuff happening at IBM, Ansible project. There's a cool chat startup in Durham called Operable that makes this Cog chatbot that's like really awesome. I'm just amazed by some of the stuff going on here, and wanted to give a big thank you to the organizers for bringing this community together. And so let's give them a little round of applause. Great job, and thank you. Okay, so I'm Aaron Suggs. I go by K-Theory on the internet. All right, great, it's animating. I run the operations engineering team at Kickstarter, and I like to think that now that you've seen me dancing in a grizzly bear coat, there is nowhere to go but up in this talk. So yeah, like I mentioned, I work at Kickstarter. This is a funding platform to help creative projects come to life. It's a really special place for me. It's a public benefit corporation, which is an interesting thing for a company to be. It not only has this sort of sustainable financial profit motive, but it also has a social good mission in trying to improve the kind of creative and independent culture that we want to have in society. And so in my role there, it is my job and my passion to make tools and processes that help teams do awesome work. And so the particular thing I wanted to talk about today was how we rolled out the ELK stack for centralized logging, and also my experience as a new manager. And just some honest talk, I don't think training engineers to be good managers is something that our industry as a whole does particularly well, and there's a lot of people sort of struggling to figure that out, and so I'll talk about some of my experiences. So ELK, for people who might not be familiar with it, is a collection of 3 tools: Elasticsearch, Logstash, and Kibana. Elasticsearch is a sort of sharded, horizontally scalable storage engine for documents. A lot of people use it for full text search as well. Logstash is this sort of ingestion tool. So you send your log data to Logstash, and like it does some transformations or whatever you need to get it into Elasticsearch. Kibana is the front-end visualization tool. It's a web app that easily generates complicated Elasticsearch queries and lets you see this data as like histograms and that sort of thing. So yeah, first management lesson I wanted to talk about, sort of kicking this off, is that it's not exactly a promotion, it's a career change. That suddenly you went from being a reasonably experienced engineer on the team to now being the most junior, inexperienced manager at the company. And taking an extra dose of humility and realizing there are a lot of unknown things, unknown skills that you don't have yet that you're going to need in terms of making plans, communicating those plans, figuring out just like how to work with different types of people. These are going to be your job now much more than writing software, and like your software development skills are kind of the icing on the cake now. And so with this lens, rolling out this Elasticsearch cluster was one of the first projects where it had been like the ops team was just me, and we hired somebody else, and he was doing a lot of the implementation, and so this was the first project where like I was the manager. And so I wanted to give credit to this other engineer. Kyle Burkhardt is an awesome DevOps engineer, and a lot of the ideas and the implementation here were his, and I just wanted to acknowledge that this wasn't all like me being clever, it was a lot of Kyle being clever too. So thinking back of like what the problem we wanted to solve with centralized logging was, you know, what are the sort of business requirements here? The status quo before we had this was pretty terrible. We had a bunch of servers running on AWS, and if developers wanted to look at the logs, they would SSH into that server and like tail and grep the logs. Since we had close to 60 servers, this was like a really inconvenient thing to do if you wanted to like find the needle in the haystack of like where's that one error or something like that. For retention, we had a cron job that would upload the log files to S3 every day. So if you wanted to look at something like more in the past, you would download probably tens of gigabytes of logs to your laptop, and you would unzip those and grep through those. Obviously, this was really terrible and really inconvenient. There was a lot of room for improvement. And so the real business value of us having a centralized logging solution was just to make it way easier for developers to investigate the sort of current status of our infrastructure, or the current status of like what was going on in our application in nearish real time. We also wanted to have more ephemeral instances. Like we were running these AWS EC2 instances for months or years at a time, and so we didn't really worry so much of like, we didn't have to worry about like losing logs as we shut them down as much. But we wanted to have like servers that we could shut down more or less instantly, and that meant getting the logs off those servers in near real time. So, you know, we wanted a centralized logging solution. We start looking at what's available out there, and we kind of were a little bit overwhelmed. And I think Charity Majors really captured this well, talking about the sort of Cambrian period we are in the operations community. There are like new awesome tools that solve huge problems better than ever coming out like every day. And it's a full-time job just to like read the blog posts and announcements and keep up with like what the best Docker scheduler is and what the simplest way to do log management is and these sorts of things. I just want to sort of like acknowledge that can be a source of stress, and like people talk about tools and you're like, I've never heard of that. I have no idea what that is. Or like, yeah, maybe I know that it exists, but I don't really have a deep understanding of it. And I feel that way quite a bit. I think the healthy way to react to it is to just sort of be humble and be willing to learn, and really just be comfortable admitting that you don't know stuff. And yeah, I've seen some discussions where it's like people sort of back themselves into a corner just because they like don't want to admit that they don't know something. And as an industry, we can do better at that. Anyway. So thinking about like what the actual simplest thing we'd want to roll out is, we started with like a hosted SaaS product. If we wanted, thinking about getting the most bang for our buck, what's like the least amount of developer effort we could spend into getting this centralized logging solution, it would have been a hosted SaaS product. Something like Papertrail or Loggly. And if you're a small team, like this is definitely the scarcest resource you have is developer attention. But for us, we decided to not really go this route because it was too much of a brand liability. We would have been a reasonably big customer, and the log information is just like so sensitive. That is like everything that happens on our system. And we just wanted a bit more control over that, even though we knew it'd be more effort. So what's the next easiest thing? Splunk had a reputation for being rather easy to, or like relatively easy to roll out. It had a big community of people using it. We started to go down this road, and honestly, it was just kind of weird at a lot of steps of like even finding out how much it would cost. We couldn't like look at Splunk's website. We had to like talk to a reseller to like give them a quote, and they need to know all this information. And we're like, we don't even know how many logs we want to send. Like, we can make a wild guess, but like we kind of want to just like start trying it out. And so it's just like it was sort of like this cultural mismatch of the way I'm used to buying software, and it didn't seem like the kind of thing that we'd feel really good about long term. And so that's where we sort of ended up with Elk. We were really impressed by the Elasticsearch community and the Elastic company doing really cool stuff. Every day there were like new blog posts about people solving hard problems with it. And yeah, so it seemed like there was a really vibrant community, and it also had a lot of momentum of like things were getting easier. They were shipping great new features every day. Versus Splunk, there was sort of this calculus, or we did this little like thought exercise of like 3 years from now, is it more likely the case that we're going to be like, thank goodness we picked Splunk, and like it was really easy to get running, but you know, we're happy with it, or are we going to feel like, oh, we're stuck there, and we wish we would have gone with this other tool that was that has become a lot easier to run over the past several years. Given that momentum, like that's what sort of tipped the scales for us. That said, like there's a lot of uncertainty about how hard it would be for us to do Elk, and it was sort of like Splunk was our backup plan. You know, if it was hard, we'd go back to that. So I also wanted to call out the Logstash book by James Turnbull. It's a really, really helpful resource, and we looked at it constantly as we were building this out. If anybody else is doing Elk stuff, like I highly recommend this book. Okay, so this is the sort of tech stack that we ended up with, and so information is sort of flowing top down here, I guess. Yeah, app logs over here. So we're using LogRage as a Ruby library because we're a Rails application. So LogRage is a Ruby library that formats Rails log messages to be much easier to use with the rest of the Elk stack. It's basically like one line of JSON per event. This is more or less trivial for Logstash to parse and ingest. Then running on every app server is FileBeat, which is it's a really lightweight log shipping tool. It's more or less like tailing the logs and sending every new message off to Logstash. We have a cluster of like 6 Logstash servers that's like plenty of capacity for us. The Logstash server is taking these like sort of real-time logs. It is archiving them to S3 because we wanted that durability and retention. You know, whatever breaks, like if we break Elasticsearch, we can still go back to S3 and look up what really happened. And then it's also going into Amazon's managed Elasticsearch service, which sort of comes bundled with Kibana running in it as a plugin. Yeah, I'll talk more about each of these too. On the vendor log sides, by vendor logs I mean things that are like our CDN access logs. We had a bunch of different kinds of log files that we weren't generating ourselves from our app, but were instead like coming from other people that were sort of like putting them into an S3 bucket. The way we processed those was like we used S3 event notifications. So when a new file is created, it fires this event. That goes into an SQS queue. We have a little Ruby process reading those messages off, sending them into a different Logstash server, and then those would go into that same Elasticsearch cluster. So we had an idea of what we wanted to build. Now it came time to like actually build it. And so this is sort of like montage portion where you just imagine people typing furiously. The way I like to do proof of concepts is sort of imagining a spiral process where, you know, eventually you're going to fill out a whole circle where you have a reasonably complete product or solution, but we're going to start with like the little nugget in the middle, which is something like, you know, get Elasticsearch running on your laptop and get Logstash running on your laptop and like send some toy log data in, and then you sort of improve it in different dimensions and just make it more and more robust. So next you would run it on AWS, and then you'd like send some test data into that, and then you'd like maybe scale it up so it's multiple servers on AWS. You'd make it a little more resilient here, and you'd make it more high performance there, and then you'd make it easier to deploy, and you're just sort of going around and around until you're at this point where you're like, okay, I've made this thing that I feel kind of comfortable with. an interesting choice we'd made was that, as we're doing this proof of concept, we were so excited to show this and like to show this to other developers and get real data in there that we'd sort of punted on a bunch of things we knew we needed to get to, of making it more resilient and doing performance testing and that sort of thing. But for a small team, we'd honestly just been like, oh yeah, okay, we can do that eventually. But we just wanted to like show people we knew that existing log process was so painful. We got to the point where we wanted to start sending our real production app data into FileBeat. And so this was the first time we needed to touch production infrastructure, right? So as we were setting up Logstash and Elasticsearch, it was our production cluster, but it wasn't really being used. It was sort of off to the side doing its own thing. Now came the moment where we needed to to run FileBeat on all our app servers, and it was going to start tailing these new logs into our cluster that we thought could handle it, right? And our mentality here was like, do no harm. We wanted whatever crashes with Logstash or FileBeats or something like that, we don't want to impact our running Rails application where like people are giving us money. Don't break that. This was almost the case. So to talk about what happened, I wanted to do a little bit of trivia time, poll the audience. So I bet somebody knows the answer to this. I'm hoping somebody does. Why might a disk be 100% full even after you remove several big files? This is a Linux system. Anybody want to just shout out the answer if you have a guess? There you go. There you go. So some process has open file handles. Well done, everybody. And if you didn't know that, you can tell your manager like, hey, I definitely learned something at DevOpsDays. So right, you remove the file, but if something is still holding on to that, like you need to kill that process, or I don't know, get that process to close the file somehow. Way to debug this is the lsof command for list open files. It'll show like all the open files that are like probably still existent, but also show you like deleted ones, and they'll have a little like deleted in parentheses. So, pro tip. So this was like a problem that our disks are full because FileBeat is holding on to a bunch of these things, probably because like Logstash had crashed and FileBeat was like out of sync of like what it had thought it had sent to Logstash. So what do we want to do about this? There was one school of thought of like, oh, we could really just like really try to reproduce this problem. It didn't happen very reliably. It was hard to reproduce because it just happened on one server every once in a while. Do we want to like, do system call tracing and that sort of thing? Turned out there was a pretty easy solution. Like we checked GitHub release notes, and sure enough, there was like, hey, we released a new version of FileBeat that like doesn't have as many bugs with like open file handles. And so we're like, oh, right, okay, we'll just upgrade it. And then it happened much less frequently. We also just like restart FileBeat from time to time. This is like the kind of thing that I do as a software developer, and I feel kind of conflicted because I'm like, I know I could really look at this hard and like have a deeper understanding of what's going on, but from a practical standpoint, it happens so rarely. Like we can, every couple months when this happens, we'll just restart it, or like we'll make a cron job that every once in a while restarts FileBeat, and we just don't have to worry about it. So yeah, honest talk, like we do that kind of thing all the time. And I really think it's a practical trade-off of like, you're not going to do a deep dive on every single bug, and really be judicious when you want to pull out that sort of really intense investigation, and when there's like just an easy pragmatic fix. It was also nice that our application, this revealed a small application bug where our application wouldn't always work correctly when it had a full disk. Part of the remediation was like, oh, we want to get our application to the state where it more or less works even if the disk is full. So revealed that bug, and we gained some resiliency there. So I wanted to talk about the choice of using managed Elasticsearch versus the next best alternative for us, which was just like running Elasticsearch ourselves on EC2. There were really trade-offs either way. We were already doing it ourselves on EC2 for Kickstarter's like product search. If you're searching for products, like that's a Elasticsearch query behind the scenes. But I'm sort of a sucker for managed services. I see that and I'm like, hey, this is theoretically easier, right? So in this trade-off, presumably a managed Elasticsearch service would require less developer attention, right? We just make this API call and we have our cluster up and running, whereas doing it ourselves on EC2 is going to be more work. We need to write the configuration changes and stuff. So that's a win for managed. It's a lot less flexible. We can't hack it, configure it, do plugins. So that was a win for doing it ourselves on EC2. It's also really hard to debug managed Elasticsearch right now. I hope this gets better, but basically the only visibility you have is that you have a CloudWatch metric that your cluster is red, and you're like, okay, it's red, like file a support ticket. Like we can't see much more. It's really easy to, on doing it ourselves, we would have had a lot more sort of operational visibility. The sort of kicker for us was that it seemed like the product was really aligned to our use case. Amazon was not making a general purpose Elasticsearch tool. It was really, the features were sort of really driven towards using it as a centralized log source. And so because of that, it seemed like a fine thing for us to try for now. We always knew our backup plan was like, if we really need that flexibility or operational visibility, we can invest the extra effort into doing it ourselves on EC2, and it wouldn't be that much work. So now I want to talk about like how we got our Rails log into Logstash. I mentioned this recently, but this is a reenactment of what it's like when Rails and Logstash try to talk to each other. It's kind of the most awkward interaction. Rails logs are really supposed to be human readable, and Logstash really needs something structured and machine readable. What to do? Thank goodness there is a Ruby gem for that. Matthias Mayer, the CEO of Travis CI, made LogRage. You can really easily sort of configure what metadata, what kind of parameters you might want to include in your log. It basically makes a second log next to your human readable production log that is just like the one line of JSON per like web request. That we got. This is an awesome gem. Check it out. I don't need to say much more about it. So now we're at the point where we have real production data coming in. This is the moment where Kyle gives the lightning talk where he shows developers how they can see their logs in Kibana. People were really, really excited about this. Again, it was so much better than the status quo. We were kind of surprised because we weren't exactly expecting people to just like start using it all the time. But that's what they did, and they would run queries that like we definitely hadn't scaled, or we were under provisioned to support. And so pretty quickly it's like, oh, hey, I did something and I broke the Elasticsearch cluster. And we're like, okay, like we'll try to fix that really quick. We're like, I guess we need bigger servers. The insight here for me was that when you're developing internal tools, the MVP, or like when it's kind of done enough for people to start using it, is when it's better than the alternative. It's not when you think it's done. It's when people can start using it to be productive. I see this as sort of like a natural law, more or less. It's just, it's not like something to strive for or something like that. It's just like kind of the way it is. Of course, people are going to use something better. Even if you say it's janky or like it's not done yet, they're like, I'm willing to put up with that because the alternative's worse. And so this is just like an important moment to be aware of, that this is when you switch from like a greenfield project to like actually kind of wanting to support people because, or support it because people are relying on it to do their job now. So quick digression about T-shaped skills. This is, from a hiring perspective, this is an important thing to keep in mind, of thinking about people having a breadth of skills as like the top of the T, and then a depth of skills in a few particular areas as the vertical line. So my particular shape is I'm deep on like AWS and Ruby stuff. If there's a problem, I'm going to be like, how can we throw AWS and Ruby at it? That is my natural lens, for better or for worse. Kyle has a really similar shape as well. He's much better at Docker though. And so this was interesting, it made this really great as a new manager of like, we just were in sync about so much stuff. We both agreed about good practices and like how we'd want to build things and what risks were. This was really like easy mode kind of. But long term, there's a bit of a risk here in that you are not making you want to have as many tools in your team's toolbox as possible. So I was starting to develop this lens. I wasn't really conscious of it at the time, but like we could imagine, what if there was a different person who was like really deep in distributed systems and Go, and the kind of solutions that would seem natural to them would look more like HashiCorp products or something like that's HashiCorp's shape. So keeping these shapes in mind, I wanted to talk about our solution for ingesting vendor logs. These are things like S3 access logs, or logs that come from our CDN Fastly, CloudTrail logs. They just like appear in an S3 bucket. We did this. Kyle came up with this really awesome pattern for how we process these. I think this is really elegant and powerful. You get the S3 event. I mentioned this earlier. Goes into SQS. We have a little Ruby worker. There's a library called Shoryuken, like Ryu from Street Fighter says, and it's based on Sidekick. It's just like a little way that does like error handling and some of the asynchronous queue worker biz logic that you'd have to do, and then it puts that into Logstash. This is all very like loosely coupled, is what I really like about this. Anything Shoryuken or Logstash could break, and messages just queue up. Yeah, so I sort of look at this solution and we're like, we love this solution, but this is also what AWS and Ruby people would like see as a good solution as you're dipping your toes in the water of distributed systems. But yeah, I highly recommend other people using it. Though I know the Ruby Gems infrastructure, I help them implement a similar thing to get download counts in. We also use it to re-import old logs. So because Elasticsearch storage is so expensive, like we only keep about 2 weeks of logs, sometimes we want to get logs from like a month ago. To do that, our process is so simple, and it's like reusing existing tools. We just queue up these SQS messages to re-import these old logs, and sure enough, they like show up in our Elasticsearch cluster a few minutes later. Trick here is to put UUIDs as the events, as the log record identifier, and that so in your Rails app, you would like generate this UUID and put that in the log. That lets this whole process be idempotent. So you can like re-ingest the same log over and over again and not get duplicate events. So we're auto-scaling the heck out of this system, right? We're like, based on the SQS queue size, we can ingest, we just spin up more and more of these Shoryuken and Logstash workers, and then we run into kind of a bad problem. So we're going to do trivia time again, right? And this is for the distributed systems thinkers out there. So like, as you scale your Logstash ingestion sort of part of the stack a lot, what becomes the next bottleneck? So like, anybody want to throw out a suggestion of what the limiting constraint became? It could have, so we would just paralyze more network traffic with more Logstash boxes. This is a trickier one. It's kind of not very well worded. It assumes like you didn't know we were scaling Elasticsearch as well. So we ended up with 100% Elasticsearch CPU. It's just, yeah, the cluster couldn't go any faster. We then encountered a particular bug that Elasticsearch would just crash. And because like this was really sad, and because we were on managed Elasticsearch, the only book that we could consult for advice was this O'Reilly book. But honestly, I mean, I got to give them credit. They gave us some like really good performance tuning suggestions. We fixed our shard size. We were not experts at like scaling Elasticsearch, and they have people who are really good at it. So even though we've had some problems, I feel like it was still a good use of our time overall. One of the last things I wanted to talk about was the mitigating burnout. So we got to this phase of the project where Kyle had done like a lot of the hard stuff of like getting these tools that we working at this scale that we weren't familiar with before, and then it came to like this sort of more tedious part where it's just like actually writing the scripts to like import a bunch of different types of logs. And looking at his backlog, it was like 12 different types of logs that were just like, go ahead and import all these things. And I noticed Kyle like wasn't really enthusiastic about it, and he was honest about saying like, this kind of looks, this is not what I'm looking forward to doing. And so this was like a management lesson of like, what do I do about it? I want to keep this great engineer happy. We also had a couple other engineers on the team at that time, and the trick that ended up working really well was to do pairing. And so Kyle would sit with another engineer and be like, I'm going to show you how to ingest this new kind of log, or like to write that Shoryuken library that's going to process this thing. This was awesome because other engineers were like, oh, I know Kyle's doing this cool thing with Elasticsearch and Logstash, but like I have no idea how it works. And so this was like their insight this was like a very practical way for them to get insight into that. We did cross-training, so we solved that hit by the bus problem. There was also team bonding. I got to see like engineers sitting together like happily talking about stuff in a room, and it just warms my heart. Yeah, so it's career growth because other people are learning stuff. Kyle's learning to be a good mentor. Yeah, so this was great. And so that's really all I had. Sort of wrapping things up to sort of put a little bow on it. As you're choosing tools, keep in mind the skills that are on your team right now, and know that that's sort of affecting what options you consider. Keep in mind the next best alternative is like what you picked turns out to not be that great, or something else like it comes along and is better. Be ready, be vaguely aware of what's going on there, and know when you should bail. Also consider the community around the tool, and I think the community is really important because it is a indicator of the trajectory and a momentum that a project has, and it helps you predict what's going to be the best solution, not today, but like in the future. That's all I had. Thank you, everybody, for your kind and generous attention. I know I'm a little over time, but I would gladly take questions out in the hallway or hit me up on Twitter. Thank you.
I think we have time for a question now. Anyone have a
Sure.
question?
Hi. Have you considered other open source solutions like a Solar, Vuon, Tableau, Hue?
Not really, because we were already aware of, we were already using Elasticsearch for Kickstarter. Wait, do I need to talk here? Yeah, we were already using Elasticsearch for like the other side of the Kickstarter product. We figured it, honestly, like I just wasn't aware of that much momentum going on. I didn't like see those blog posts or those sort of product announcements of using that for centralized logging.
I think like the Elasticsearch is from the same indexing engine, Solar.
Like Lucene under the hood? Yeah.
So when it comes to the centralized log monitoring or analyzing, so it's going to, if it scales up to the big volumes, it's going to kill the network. It's going to kill the storage. So.
I mean, one of the Elasticsearch features is like doing this sharding to horizontally partition stuff. So as you see your storage, like really we scale out on storage. That's our bottleneck for Elasticsearch. If we want to store more, we just launch more servers.
Okay.
Or it's really like the API call to like tell AWS to make it a 10 node cluster instead of a 8 node cluster or something.
Okay, one last one.
All right.
How you